Hello, this is Mrs. Scarpel, and I am going to go over the arithmetic you can do with matrices. On this first slide, we're going to add or subtract matrices. In order to add or subtract matrices, the dimensions of the matrices must be the same. They must have the same number of rows and the same number of columns. And then when you add them, you add their corresponding elements. So our matrices are going to, our answer matrix, our solution matrix, is going to have the same dimensions as the matrices we are adding or subtracting. So I'm going to try to do some color coding here. To find my first entry, I'm going to add 1 to negative 5. 1 plus negative 5 is negative 4. Then I'm going to take top row, second element, so we have 4 plus negative 4 is 0. Top row, third element, 4 plus negative 1 is 3. Bottom row, first element, negative 1 plus 6 is 5. Bottom row, second element, we have negative 4 plus negative 4 again, which is 0. And then we have our last elements, bottom row, third element, negative 6 plus negative 2 is negative 8. And this is our answer. This is how we add matrices. When you subtract matrices, much like solving equations that have a subtraction or simplifying an expression that has a subtraction between two items, especially if it's something that would involve possibly distributing, we need to keep that in mind with subtraction as well. So what I'm going to do here is I'm going to rewrite my problem. The first matrix is going to stay 0, 6, 2, negative 4, 5, 4. Then I'm going to write plus, and I'm going to write the opposite of every element in this second matrix. So instead of a minus 4, because we have the subtraction, it would become a plus 4. Minus 5 for the top row. Negative 5, negative 4 for the second row. Negative 2, negative 3 for the third row. Then I'm going to combine my elements. So I have 0 plus 4, which is going to equal 4. But then we have 6 plus negative 5, which is 1. Second row, first element is 2. Add that to second row, first element of the second one. So we have 2 plus negative 5 is negative 3. And then we have negative 4 plus negative 4 is negative 8. And finally, we have the third row, first element. So 5 plus negative 2 is going to be 3. 4 plus negative 3 is going to be 1. And our final answer is the same dimensions as our 2 that we subtracted, 3 rows by 2 columns. The next thing I'm going to show you is scalar multiplication. When you have scalar multiplication, you have a single value in front of a matrix. Sometimes it's written as negative 2 times the entire matrix. It means the same thing. You're going to take each element inside of the matrix and multiply it by 2. So our new matrix is going to be 2 times 2 or negative 2 times 2 is negative 4. Negative 2 times negative 5 is 10. Negative 2 times negative 4 is 8. Negative 2 times negative 3 is 6. Negative 2 times 5 is negative 10. And negative 2 times negative 1 is 2. So scalar multiplication is really just like the distributive property. You're multiplying it with every single element inside the matrix to get your final answer. Now, for the operation that is not so straightforward, that's matrix multiplication. One thing you need to check first of all is your dimensions. So this first matrix is a 3-row by 2-column matrix, and the second matrix is a 2-row by 2-column matrix. In order to be able to multiply these, the number of rows in the first matrix has to be the same as the number of rows in the second matrix. The outside values give you the dimensions of the solution. So we're going to have 3 rows by 2 columns. For our answer. So I'm going to write this one out in a couple of steps. First, I'm going to take the first row, each element in the first row times each element in the first column of the second matrix. What's going to happen is I'm going to take 1 times 2 and add it to 4 times negative 2. To get the next entry, I take that row times the second column, and that's going to be 1 times negative 4 plus 4 times 6. Then I go to my second row, and I do the same thing. Second row times the first column, so 1 times 2 plus negative 5 times negative 2. And then we have 1 times negative 4 plus negative 5 times 6. And then we have the third row times each column. 1 times 2 plus negative 2 times negative 2. Take it times the second column. 1 times negative 4 plus negative 2 times 6. And then I'm going to simplify. So here we have 2 plus negative 8. 2 plus negative 8 is negative 6. Then we have negative 4 plus 24 for a positive 20. 2 plus positive 10, because we're multiplying 2 negatives, so 2 plus 10 is 12. Negative 4 plus negative 30 is negative 34. And then we have our last row. 2 plus 4, again we're multiplying 2 negatives, so 2 plus 4 is 6. Negative 4 plus negative 12, that is negative 16. And that is our solution when we multiply. So it's always taking a row times each column. And that's why the number of columns in the first matrix has to match the number of rows in the second matrix.